Alright, our next function that we're going to talk about is what we call the cubic function. Okay, the parent function of the cubic function is f of x equals x cubed. So let's take a minute and let's go ahead and let's graph what the parent function looks like. So once again, we are going to make a chart. There we go. Okay, and we are going to have our x's, and we're going to have our f of x. And let's go ahead and use -2, -1, 0, 1, and 2. Alright, so f of -2 would be the same as -2 cubed. So we have to think. This is like saying -2 times -2, which is +4, times -2, which gives us -8. Okay, now we do -1. So f of -1 is -1 cubed, okay, which is -1 times -1, which is +1, times -1 is -1. Okay, 0 cubed, 0. 1 cubed would be 1 times 1 times 1, which is 1. And 2 cubed would give us 2 times 2 times 2, which gives us a +8. Alright, let's plot these points. So we go -2, 8. So we're going to go off the graph a little bit. We go -1, -1, 0, 0, 1, 1, and 2, 8. Alright, so connecting. We have this nice cubic function. Alright, so it kind of looks like an S in a way. And we're going to get more into the cubic function in a later unit when we talk about polynomials. So we're just going to cover our basics. Well, this is a nice one to remember. Your domain for x, well, this graph is going to get wider and wider. So x is going to be equal to all real numbers. And at the same time, with the range, it's going to be going up, 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 and down, down, down. So y is going to be all real numbers. No matter how you transform this graph, your domain and your range will always be all real numbers. Okay, now for the important part, the transformation function. Once again, we have A, H, and K. H is still a liar, but this time we're going to have f of x equals A times x minus h cubed plus k. So the only thing we're changing this time around is now we have a cubed. So it's still all the same. H is still a liar, it still moves it horizontally. K, we take it as we see it as vertical. And A will cause our graph to open wider or get skinnier, and it could flip it. So let's take a look at an example. Let's say we have f of x equals -x cubed minus 2. Alright, so above it, let me change back to black here. Here's our transformation function. Alright, oops, not 2. I guess I gave that answer away. That should be a plus k. So our -2, since it's outside our parentheses, is our k. Because it is negative, so k is equal to -2, that means we're going to go down 2. The negative here once again means that we reflect over the x. Then that's the x-axis. So let's make a table to see our values so we can kind of see what happens here. So we'll once again use -2, -1, 0, 1, and 2. And then we have our function. Well, we know that -2 cubed, so we're just plugging in -2, we know that -2 cubed is going to give us a -8 because we just did that. Well, now we want the opposite of that. So now we're to a +8, and then -2 gives us 6. So once again, we've got to follow our order of operations. Okay, we know that -1 cubed gives us -1. The opposite of that is +1. So now we want 1 minus 2, which gives us -1. Well, 0 cubed is 0. The opposite is 0. -2 is -2. 1 cubed was 1. The opposite is -1. And -2 is -3. 2 cubed was 8. The opposite is -8. -2 is -10. Now, if you need to, you can use a calculator, but you would have to enter it in exactly how I have up here so that your calculator follows the correct order of operations. All right, so let's plot this. -2 sixths, -1 -1, 0 -2, 1 -3. Oops, I went the wrong way on that one point, didn't I? I was wondering why it looked weird. So we need to go -1 -1. There we go. And 2 10. So we're kind of off down here. All right. So now we can tell this is quite a bit different from the first graph we did, the parent function. Let me go ahead and just do a quick sketch of the parent function here. Okay, so we can tell that we've reflected it. If you were to fold that in half, it could match up. And we've also moved it down too. This point here, this 0, 0, this doesn't have a vertex because there's no minimum, there's no maximum really. But that point is kind of like your vertex. It's your starting point. So we're always going to want to see how we move that. And then the next thing is saying our domain and range, which should be hopefully easy. What's your domain? Always, always, always. X is equal to all real numbers. And then your range, always, 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 is that Y is equal to all real numbers. All right. That is it for this video. Like I said, this is kind of the basics of it. Not much is going to change from here. So we just need to remember what A, H, and K do.